just a quick talk, just a quick talk. I just want to go through and tell my own story, okay? How I ended up like starting to learn some procedural tools for my own job, the actual job that I go every day and live upon that. So I just named my talk cogs and brushes. So you will realize why I named my talk to that. So I'm gonna talk about why thoughts are more important than tools. For a long time, especially like 16 years ago that I started CG, so everything was new for anyone. So any tool that you get involved and work with that was like something amazing. That's why, so if you just spend some time and work with different tools, you could get a lot of money because other people couldn't. But slowly, just not me, the whole industry, we realized that it's not about tools, it's about thoughts and creativity and the people. So I'm going to talk about a very sad story, the unfortunate fate of XSI. For a long time, XSI was a very important tool in production pipelines. So so you can see for this game, Metal Gear, or for a very successful TV series, Pocoyo or Jelly Jam, XSI was the main tool for these productions. And really large companies like Miele and Glassworks, they were all using XSI. And suddenly, Autodesk bought XSI and just discontinued the product. Why? Because of money, because they wanted to use those tools and embed it into their currently developing tools. So a lot of people ask if Autodesk can just issue the source code, so independent developers can develop the tool, but they just avoided that. So that was a good lesson for every one of us. So we just learned that we should not trust any company. So if you just ask Adobe, we really need a GPU accelerator on Photoshop now, Adobe will say, oh, fuck off. We don't give you that tool. And you just compare Photoshop from the current version that you got with the version that you have like 10 years ago. It's more or less the same. So they just develop new ways of emptying your pockets, subscription of different marketing strategies instead of investing in the actual tool that you need. So it's about 3-4 years that I started to so I jump into any tool that I get and I experience it. And these are the main things that I consider. Well, not only me, most of my colleagues that I know, they're like that. So they if a new tool just gets introduced to the market, if it is accessible, there's a free license, we just download and start to play around with that. It should be easy and can be learned quickly. If I have to spend more than 3 days, I don't want it. If it can be started to get, if you can start to get to know something within 3 days, okay, let's do that. That's why I have not started learning Houdini. You know that, how lazy I am. So I was like, everyone was talking about Houdini for a long time, and I was like, it's too hard to learn. But the tool has been developed, especially the latest version 16. I'm going to talk about that. So lots of things has changed. So it has become much more easier to be learned. The tool should be flexible. So if the director says, okay, put this from here to there, I want the fire to come out of the mouth of the dragon, and now from the ears of the dragon. It should be flexible. You have to be able to play around with that. And you have to be So ideally, you have to do all cool stuff by just pressing a button. So it's, well, that's just a joke. You can't find such a tool. But most of the tools that we're using these days, they're becoming like more and more automated and advanced. So like a GPU accelerator rendering engine is like 10 times. So Arnold was like a revolutionary tool when it got released, but now GPU accelerating renderings, they are 10 times faster than Arnold. So why not using them? So whatever I find, I just dive into that and I try them. That's why. Okay. So why Houdini? What I found, Houdini is a way of thinking than a tool. The success of this package, this software package, is that it helps us to think in a different way. So it's like thinking procedurally. What is thinking procedurally? It's like if I want to model this, if I want to create an explosion, if I want, so let's say this is the movie shot that we're gonna work on. This is the game scene that, so when I'm here, when I run, and if I cross over here, something explodes. The ground explodes, and different pieces of. So I have to start analyze things step by step. So okay, I need to explode the ground, but I have to tear apart the carpet. I have to add dust. I have to add different shards. I have to create some. There might be some iron rods in there. So what about them? So you think about a procedure and you apply things one after another. And well, the very basic idea in Maya is that you can do that as well, but you will get lost in Maya very soon. So if you work in Maya and you look at the node editor in Maya, I don't see anybody. Just, can you open your node editor here, Dasha? Sorry, I'm interrupting you.
No.
I'm not gonna. So just look at the simple node editor in Maya for like just a simple object. Maybe the character. I'm gonna grab your character. Maybe. Yeah, so a simple node editor in Maya becomes too complex too quickly. Sorry about that. So it's not usable. So if you want to tweak something in node editor in Maya, it says it's procedural, but it isn't. But imagine that you have, so any action that's in any decision that you make becomes a node. And this node becomes part of your production. It helps you to create, infinite iterations. Why iterations are very important? For now, you get some assignments and you start working on them, and your lecturer says, okay, that's fine. A or B or everything goes fine there. But in industry, in an actual job, you have to be able to reiterate your job as many as client wants. So sometimes we end up like doing like 30, 40 iterations of one single job, and then we just, I cannot tolerate opening a new scene for this client anymore. But imagine that your tool would be iterative enough that you just, okay, the client wants the hair to be red instead of blue. The clients want the fire to be yellow, and they want instead of fire they want ice or dry ice, smoke. Oh, things just becomes so once things are too complex, when you have a proper iteration and a proper structure, procedural structure, you can review your job again and again and again. Okay, this can be felt in two main industries: VFX industry and game industry. I'm not gonna show you too many videos, just too few. Um, there's no sound, I believe.
Tim, don't get too excited.
We started working on our
Yeah, man.
Is there any sound
He
somewhere?
like pops up in the seat. You know, it's too much.
Doctor Strange in August in 2016, finishing around
Okay,
90 shots for the
just
final movie,
I.
including effects like
Ah, okay. Yeah, I know what you have.
Audio, you're trying to do audio.
Yeah, I'm gonna have. I'm gonna tell the.
Hopefully we won't blow it. Hopefully we won't blame it on. Portal is my best. Can you open a portal? Because I can. I've forgotten how to do it now. That's the worst part. I'm so embarrassed having to watch that.
Okay, that's a very good review of.
Oh, look at that. Look at that whip.
So if you just look at what they did, those strings and ropes, they seem really cool, but the procedure that they went through, when he explains, seems very reasonable, and you say, okay, things are so logical and so achievable.
LED ropes. These whips, which were then later replaced by our boards. So to get a really photorealistic look, because the lighting was key. We used the rotonated geometry and lit it with volume light in Houdini that was based on the whip geometry that we generated. The whip setup itself was like more like a procedural modeling setup in SOPs than some simulation. We rendered the whips as a huge number of points. In the initial position, the rest position, where it was just a straight loud whip, we would animate a 3D noise through it to get the pulsating movement, and had another noise that would really move the strings themselves to get this sine waves moving through it. We generated a p-scale attribute based on the noise, and this was used to then feed this in a point replicate. So we got even more points, but they were all of the same size, and with an edited shader, we got to the final result for one layer. And the other layer was using those points again, converting into a volume, and generating an additional temperature volume, so we could then use this in a pyro shader and tweak the shader as if it was a typical pyro sim, but all based on procedural modeling techniques. Other very important layer were the sparks, and they were actually the layer where we spent most time on, because they got a very distinct look. We could not just render points with motion blur, because we needed to have full control over the fading within the motion blur, and also we wanted to add some noise in the motion blur. And the options we had were to like simulate with lots of substeps, but we decided to build a tool that generates lines. So we didn't end up rendering with motion blur, we would just generate it in SOPs using ramps in Houdini to say 5% should have this extreme noise, and most of them shouldn't, and like control every aspect of the look. The portals they generate Doctor Strange and the Sealots to fast travel in the world. The sparks themselves were a pretty straightforward setup using pop.
Pretty straightforward.
We were looking based on our rotating circle that had some noise mapped onto it for the mission, and that we also generated a velocity volume, so we could, in addition to the inherited rotating velocity, also add some curl noise to it to get this distinct look. We used a simple metaball force in the middle to prevent the sparks from entering the circle, and then some other custom volume forces to just spread it out in certain areas.
So you see, it's all about analyzing what you want and then trying to apply that. I've got a nice video for the game industry as well. So the use of Houdini in games are becoming more and more ubiquitous everywhere.
The games industry is facing an the same time as the volume of content is exploding, the budgets are not exploding for making these games. And so you have to use the same resources, the same number of people to generate hundreds or thousands of times as much content. And the only real way of approaching that is to build tools which work procedurally to allow you to be that much more effective and productive.
Houdini helps us remove the repetitive and robotic tasks from our dev pipeline. Or any task that's going to have a very limited cost, just due to the amount of manipulations that the content creator is needing to do.
We are typically 5 to 50 times faster when we're working procedurally.
We saw something that would take us 2 to 3 days go down to 2 to 3 minutes.
Yeah, Houdini's, I think it's changed my creative process in how I approach looking at a problem. I appreciate the fact that I can use the technical tools that Houdini provides to create an artistic solution that would probably be possible in other tools, but it would be as easy to implement.
Oh.
The cinematic quality gets pushed up quite a few notches when you're using Houdini. We want to have feature film quality visual effects, and Houdini is well known and used across the film visual effects industry. So we also want to kind of get that AAA talent from film, bring it into games, and kind of bring up that quality bar.
Okay. And don't forget SIGGRAPH papers. I was always asking myself, you know what is SIGGRAPH? It's an annual conference that the latest achievements and discoveries in computer science will be presented in that conference. So this is for this year, for example. And lots of amazing papers. So by paper, I mean someone, a mathematician or a computer scientist, they develop solutions for different problems. And those solutions are like actual issued paper in different journals with lots of mathematical formulas and stuff like that. But we need, so.
This video is just a few clips from the amazing work to be found in the SIGGRAPH 2017 Technical Papers program. In this work, more than 200,000 animated colored point lights provide efficient volumetric lighting for this scene. The new multi-species model can simulate the interaction between water and porous sand as this dam is breached. This new extended finite element method robustly handles cutting this rubber plate with an arbitrary and complex cutting path. A new integration method accelerates accurate simulation of stiff systems like the motion of these fine strands of hair. This new near and far field reflectance model handles light scattering through the fur of this hamster.
Surprisingly, these are not like super secret confidential technologies. So you can go and read through all those papers and regenerate these effects if you can. So it would be lovely if someone grabs these papers and every year. So if we have a modular system, so if I have like a modular, do you know what is modular? So like a Lego. Lego is a modular platform. So you can break it apart and assemble again and make a new things. But the very essence is the same. So it's like some basic blocks. So you can build up anything with those blocks. If we have a modular system, that we would be able to disassemble that and then add a new technology and reassemble that again, that would be fantastic. This is what Houdini is. That's why the latest papers in SIGGRAPH, the first package that they chuck it in all those new discovers is Houdini. So it would be fantastic. That's why in every version of Houdini they come up with lots of new new tools, most of them inspired by SIGGRAPH papers.
For challenging models like this fence or a slinky.
So I just leave it for you. You can go and look at those papers. You can find them online. Many of them are available, so you can just go through and read them. Colors and compositing, for example. Just read through. This is just a summary of the paper, but you can find the actual paper online as well. What motivated me, I told you I was lazy for a long time. I don't want to spend some, I don't want to learn a new package. I was like, that's enough. Let's do whatever I have already learned. But what motivated me to start have a look at Houdini was the latest version. This version 16 is by far the most important release of this package, because surprisingly, so Houdini was like, it was like, okay, get into Houdini, do your effects or procedural modeling, and then come back into Maya. But some of the developers from XSI, they have been hired by Side Effects, and they worked on a fantastic character rigging and animation solution, and it's been released in this version. So I tried that. I tried that at work. I rigged the character, and it was fantastic. It was so there were a fantastic automatic rig for lazy people like me, soft image gear, and the infrastructure in Houdini is very, so I assume that the same people has been acquired by Side Effect to develop that. That was fantastic, really great. And Ocean Tools has been developed too, so we can create lots of amazing ocean effects and lots of hair and fur inside Houdini, much easier than before. And to me, as a beginner, this user interface has changed a lot. Lots of it has become much more friendlier and easier to work with. So that was the reason this is the time to start learn some Houdini. I spent like hours and looked through all those tutorials that are in Side Effects Houdini website. So, and I looked through most of them, and to my opinion, these three are the most important ones. So in Entagma, two lovely. So two of them are one of them is free. Two of them are like paid ones. So but none of them are beginner. So Entagma, these two lovely guys, they just they shared the tips and tricks. They are motion graphics artists, but very high level ones. So they share their what they have achieved during the last week. So what challenges they were wrestling with and how they could solve the problems. And some of them are really hard, some of them are really lovely and understandable for beginners. Rohan Dalvi, so these two are the people behind Entagma. They are like professionals. The people, what was the name of the guy? um, this Steven Nipping, he is an actual visual effects artist that has worked on Rogue One, on Avengers. So he's a real pro. So lessons he talk about and he teaches are like top notch. Rohan Dalvi is a fantastic teacher with a lovely Indian accent. The lessons, so his lessons on Houdini are some of the best ones. I really recommend you go and look at his free lessons, especially this MoGraph in Houdini. And then what we can do here in these meetups. So I recommend every one of you to start from here. All these links, let me show you. So on our Facebook page, I have posted all of this. So the slides that I'm talking about, before starting the talking, I just uploaded them. So you just click on that and you see all these slides that I'm talking about. So don't worry about missing any link. So I recommend every one of you just to start from here. This is what I did. So I'm going to talk about my journey, and I will do some stuff in Houdini today. And so this is what I did. I listened to these first 6 quick starts. They were like, every one of them like 2-3 minutes, as short as that. And then I started to think of, okay, I'm going to do this, I'm going to do that. How should I do that? Okay, what we can do here in our meetups. So as I told you, it's not about lecturing. It's about talking. It's about discussions. It's about sharing knowledge, and it's a huge area. So everyone can take a part. Someone can work. So Houdini includes lots of operations. So like operations for creating liquid, for creating pyro effects like smoke, and for procedural modeling. So everyone can take, so any one of us has some questions. So like today at work, my supervisor said, can we make a dry ice effect? And I just worked in Maya for like 3 hours, and I was like, shit. And then inside Houdini, I just jumped into the Houdini, and within 5 minutes, I could create that. And I will show you how I did it. So what we can do in these meetups, anyone. So anyone can be volunteer. I'm going to talk about, like, let's say, liquid simulations. I'm going to talk about. I have some questions about how to integrate Houdini with Unity, and then I'm going to solve that problem, and within this week, or like within the next 2 weeks, I'm going to work on that, and I will lecture and I will give a talk about that within 30 minutes. So we can have 30 minutes talks, and we can talk about new features and industry news. So as you will see, Houdini will, so some people create assets for Houdini. So that's an actual package of like lots of nodes. You can grab that asset and just use it, and you will make use of all those experiences that the guy has offered. We can group purchase of paid tutorials. So if someone, yeah, that's good. If someone says, okay, why not buy that fantastic tutorial together? So, $600 for one single person is like a lot of money, but for 10 people, it's much more affordable. We can ask questions from each other. We can talk about a new problem and then try to solve it for the next meetup. And any cool stuff beyond Houdini, as I told you, it's not about tools. It's about a thinking method, a procedure. Okay, what I'm going to do today, I will do two things. Two two quick tutorials actually to start with working Houdini. So let's jump in.
Jose,
Yes.
do you mind if I add on top of what you said?
Yes.
In terms of getting access to anything, I also have access to plural sites.
Oh.
And then in terms of, well, this applies to none of you guys, but I'll tell everyone in the games stuff because I know how to do games, and if you'd like to see it in like Unity, Unreal Engine, we can do that as well.
Game engines are becoming like more and more integrated even into productions. We are at work. We are rendering a TV series inside Unreal now because it's real time. It gives real time depth of field. It gives real time particles and stuff. Okay. I just want to do some quick review of the basic tools that you can find in that website that I told you. So I'm not telling anything new, okay? But what is nice to tell after looking at this video, 6 videos, I started to ask some questions from myself. So this is my first journey into Houdini. So I asked, okay, let's create a sphere. So I click on that create sphere here, enter. So the sphere has been added. So you know that whatever you create inside Houdini, you can. So here is you got lots of environment that to work inside that. Channels is for the animation, image for editing your images, materials, objects, art for rendering, shop for shading operations, vex is the programming. Yeah, the programming part of so scripting. So I dive into the sub layer and I added I asked myself, okay, I'm gonna add a so let me convert this polygon into polygon. Okay, like that. It's nicer. So I asked myself, okay, how I'm going to attach just for fun. I'm going to attach a tube to every one of these pixels. Okay, I created a tube, and let's click on tube. So I'm gonna create it inside that thing. So right click here. I press tab here and type tube and create it here. It's inside here. So you see that I switch between the viewing of every one of them by clicking on this eye. So this tube is too big. Just change the radius, change the height. Okay, let's look at the sphere. Can I see both of them together? Yes, you can select the sphere and by just look at the tube and adjust. Let's adjust the tube based on the sphere of the other way. Smaller. Okay, so I'm gonna distribute this tube on the surface of a sphere. What I did, I just googled how to distribute, how to blah blah blah. Okay, so this is what I did actually. So it says, okay, use copy node. I used a copy node, copy to points node, and okay, sphere comes here and tube comes here. Click on the viewing of the latest thing and nothing happens. So we have to. So how I deleted that, I just pressed Y and just cutted the connections. Yeah. Copy and transform. Maybe use that. Oh no. We need to.
You sure you had it the right way around?
Okay, so I replace that. I use tube here, and okay. So it's been added, but the direction of the tube is like wrong. So I select the tubes, and I did all this just by looking. So it says axis. So why? There we are. So I'm gonna close down the end of the cap of the tubes. So select the tubes, end caps. That's better. But where's my sphere? I just want them to be on top of the sphere. So I thought, this is what I thought actually. I thought, okay, let's merge the sphere with the result of that. So what I did, I actually literally did that. I typed if there's a merge. Yeah, there's a merge. So I'm gonna merge this with the sphere. There we are. So the image has been, so this is what I created. So I said, okay, let's, what about I'm gonna break it apart and just fall to the floor. So okay, this is what I read. You have to come out of your object network, move it up, create a collision ground plane. I don't want to see the ground plane, so I just turn off the visibility of that. You have to select your object. You have to shatter it apart inside model shatter. So it gets shattered, and some new nodes get added. It was annoying me because I couldn't see any connection between them. So I googled and I figured out that if you turn on this view show for all dependency links, oh, that's better now. So I can see that there's a link between the there's an auto DOP network, and I googled again, and this DOP means dynamic operations. So there's a interlink between dynamic operations. There's a couple of operations. So some of them are like self-explanatory, like gravity, like static solver. So it means that it turns this object into a static object. And okay, let's select this object that I created and turn it into a rigid body. So it should work and it should break. Let's play if it works. Yes, it works. But this is not I wanted. You know what? Look at that. Let me click on this clock and it becomes real time. You look at these little cubes. It's like they are separate from the content. But I wanted them to be actual part of the content. So I'm gonna undo everything. This is what I did. I'm gonna undo everything. Okay. So I go before shattering. So I ask myself, this is how I analyze that. First of all, let's convert these tubes into polygon. You can see that they are NURBS. That's better. This is what I told myself. So this is a surface, and this is a surface. So surfaces are like sliding on top of each other. What if this this sphere turns into a volumetric shape, like a fog, like a liquid, and those tubes turn into and smoke and liquid, fog again. So they merge together. So they can be merged together. So I googled again how to convert polygon into volumetric shape, and this is what I found. There's a voxel-based data set. It's called VDB, voxel-based. So I said, okay, everything should turn into a fog. So at the beginning, I just converted this to the volumetric shape, and then converted that, and then merged them together. But then I realized that you can convert the outcome quickly, VDB from polygons. So it turns into a volumetric shape. But this volumetric shape, the resolution is too low. So what is voxel? So voxel is actually 3D pixels. So let's say you add 3D pixels into this shape to define this shape. So the tinier the pixel, the higher the resolution. So the voxel size is like, so I turn it into, okay, that's better. Even maybe more, like 1.7. Okay, that's enough. They are like volumetric things that has been fused into each other. Can I smooth that? Let's Google that. I Googled it and I found out that VDB smooth SDF. There are two types of smooth. Stiff SDF works for this purpose better. I don't know why. I have to read more. So it's smooth out. So how you can see if this node works properly or not? You can pass that through. So what does pass through means? It means that, okay, ignore this node and go to the next node. Okay, I think I've got a nicely merged images, so surfaces together. They are like fused and melted into each other. So can I turn it back into the mesh, a polygon? That was easy because I just it didn't need any Googling. So I just converting VDB. There it is. Voxel-based data set. So I'm gonna say, okay, go back to polygon. So this is what I got. For a long time, I played around with that, and everything was like really horrible because the polygon shape was really unusual. And then I Googled again, how can I remesh things into a proper mesh? And it was remesh, actually. Okay, remesh added. And then I clicked on that, and yeah, that's better. But it's a bit dense. Maybe I want to break apart into 100 pieces. So I need and this computer is not fast enough. So let's make it like 2 iterations. Wait. Okay, that's a better mesh. It's easier to calculate, but it's very ugly. It's not smooth enough. Is there any way so I can smooth it? Smooth. Yes. Okay. Tap. Smooth. So this is what actually happened to me. I was thinking for a solution, and I was like, step by step, I was receiving the answer for those solutions. So it is smooth. Now you see that we started from here and we reached to here. That's a much nicer organic shape. Can I break it apart? Yes. Let's do that again. Go. So I was inside the network. I just go up, shatter part. So for shatter, I realized that if you click on this chalk center and increase this number, maybe we want this time, we want 50 pieces, a lot more. Why not 100? Let's see how.
You break it.
Yeah. So, and then we need to add a collision. I'm going to turn off the visibility and then turn it into a rigid body. You see that how links gets shaped. So let's play that. So break in 200 pieces. So the beauty of procedural modeling is that, okay, you did lots of different things on a merge between those two objects. Why? So you're happy with the shattering and stuff, but the client comes and says, okay, we got a pig head. You have to shatter this apart, not that. So just he gives you a model. So just to let you know how I added that. There's a lots of test objects inside Houdini, so you can play around with them. There's a pig head, there's a rubber toy, a shader ball, a squab, and a person, a character. So you can use them. So pig head. And why not? I press what was that? Y, and break this link. Add this to that pig head. So so let's see how it. So we don't need a smoothing. So I actually pass a smoothing. We don't need remeshing for that. I pass that. So it's better to not use those nodes at all. So what I'm going to do, I hold on Alt, and I join these two together, and then from here to here, okay, I directly go to there. Can I create fracture and stuff? Everything looks fine here. Let's see if okay. Let's see if it works with that one. Oh no. I have to reconnect some of the links here again because this is a sphere object. I have to redefine that. That was my first thing. So I just think and then find the solution and apply that. So the second thing, just do it quickly for you. Time is over now, I know, but this is so cool. Just look at that. So I learned that from Entagma. So there's a quick. So this is a simple version, a beginner version of this abstract shape that they talk about. That one. I'm gonna do that one. So abstract shapes. So let's start with a sphere. So let's see, a very complex model, how it gets formed very quickly. So let's do a procedural modeling. Sphere, I turn it into a polygon. It's NURBS when you create it. And then I turn it into ease of sets. So that's another way. So this is a way to convert it into a volumetric shape. One of them was VDB. The other one is SDF surfaces. I actually don't know what they are. They are like some mathematical way of like creating volume out of geometry. So I have to study more about that. So, and then when you use and scatter, you can scatter points inside that volume. So that's a lot of points. So I don't need that much of points. I just want some points inside that. And then I want to connect these points together. So simply connect adjacent pieces. Add it here. And points get connected to each other. Nothing happens because I have to play around with these things. It would be cool if I would be able to turn these lines into shape. Is there anything? Google that. I found wireframe is the one to turn things, but they are too ugly. So it's better to turn it into smaller. But still that's not what I like. I want them to be like very dynamic. So let's do that trick again. Let's turn it into, let me look at my stuff. Let's turn it into VDB again. Yeah. VDB from polygon. And smooth that VDB. Okay, maybe more smoothing, more and more. You see that this shape is much more dynamic. So if I turn that into, yes.
I have a question. Do you know how to add noise on top of that?
I don't know, but we can Google that.
But like VDB, maybe noise. Or maybe, because then you could have it like, I don't know, have a bit of waviness to it.
Houdini, VDB,
But noise is
noise.
Explain to me, Sean. Because we can VDB.
We can't. We can, yes.
No, I'm asking why. I'm not.
Noise makes everything pretty.
Even the tone,
I have to read through that. So just to save your time, let's do that first. I convert that VDB to so VDB convert VDB convert. We just want to to polygon and remesh the polygon. Add it again here. Click on here. We have to wait. Okay. Maybe 2 iterations because I like light meshes. And maybe smooth that a bit. Like a bird. So this is much more organic than the first thing that I. So what if I add another wireframe here? Wireframe. Okay. Let's make it smaller, like 5.
I didn't do this. I told him to add noise. This is not noise.
Oh my god.
So a procedural modeling in few minutes, and it's so cool. I'm gonna turn off that wire one, but we got a complex model. We can play around with that. So inside, so the navigation inside interface is quite like Maya. So anything. So just make sure that you are in camera, then you can navigate around. Left click, middle click, right click. Moving around, just figure that out. I don't want to waste your time on that. Just listen to those like few early tutorials. So you can, so why not? This is what I actually did last week. I just started to play around with these. Why not turn that into a lava? So let's do that. Why not?
Don't
So
say this now because Jun has been trying to make lava for so long. Yeah. And you're just gonna crush him into a million pieces.
so this is a very complex scene, mesh actually. So let's turn it into lava. I don't know if this computer can handle that. Particle separation, like
the simulation of the texture of the color.
Maybe more.
Because of simulation,
Oh yeah. Okay.
the shading.
Died.
Oh,
So
Yeah, you probably shouldn't do that.
yeah.
maybe the first creative might work, but
Oh, no.
no, that's 32. That's 16.
Calculating divisions as it says.